Yeah, hello everyone. Good afternoon to everyone present here. I welcome you to today's webinar session. And today we'll be doing a webinar session, as in the title, uh, introduction to coding with the help of Raspuri. Raspuri is actually a block-based coding system that is developed at Klaritree itself. Right. Give me a few seconds. We should start off the session in another 10 to 20 seconds. Hi. Yes, thank you for waiting. Sorry to keep you waiting. I know I'm late by another 7 minutes, but I hope everybody is ready to start. Okay, so in today's session, we'll primarily be looking at pro coding, right? In another sense, programming. And we'll be also programming, and I'll be showing you some live demos of programming along with a block-based system, right? Yeah. Okay, hopefully my screen is visible to everyone. And yes. So we know in this day and age, like electronic devices are everybody from the age of 2 till however long you, you're used to using electronic devices, right? And all these electronic devices are vast and wide, like everywhere from the most developed of the countries to the most underdeveloped of countries will have some form of electronic devices that they've ever come across, either be a mobile device, a computer, high-end computers, right? Everybody have come across this in some form or another, right? Whether it be a TV, a mobile phone, a tablet, right? Or a personal computer for many of us, right? And has any of you thought like how these devices are actually working and what exactly happens when most of these devices are being used, right? For us, most of us just see a beautiful user experience, right? We see a good screen, we're able to interact with the screen, we're able to get output from that screen, and yeah, we're able to perform operations on the screen, right? And all these electronic devices primarily have two major things that are involved to create these electronic devices, right? They are basically the hardware components that you see on the left side of the screen, and we also have the software components on the right side of the screen. Now, what are hardware components? Right? Hardware components can be anything that you can physically feel or touch. Right? In these electronic devices, you can feel or touch. So, in a mobile device, it could be a screen. Right? It could be buttons on the mobile device if your mobile device has buttons. If you have a personal computer or a laptop, it could be your keyboard, your mouse, a touchscreen if it's touchscreen enabled, your speakers, or any other such devices, right? The even your printer in this case, USB devices, all of these are hardware devices that you can physically feel or touch. Now, what are the software components of it? So now the software components of it are anything that you use to actually drive useful meaning from these hardware devices, right? So it could be your applications. A lot of you have used applications. A simple application that I can name right now is YouTube that you're using at this point to actually view this stream. Uh, it could be Instagram. I know Instagram is an app that you can use on your phone. YouTube is an app that you can use on your mobile device through Chrome. Chrome is also something that many of you would have come across. Then what other common devices? Facebook. I think a lot of you here are through Facebook also today. So all these are software components, and these software components, they're usually they're always driven by logic. That means everything that you do in a software component is actually some doing of somebody else's, is a creation of somebody else, and all of these come under a big umbrella, right? From the hardware to the software components, all of these come under a big umbrella called computer science, right? Computer science, uh, many of you here, I know we have people as low as 13 years all the way up to, I saw somebody being almost 50 years of age, right? Uh, so all of you, um, yeah. To explain to the most simplest way, computer science is basically understanding how uh, all these hardware and software components work, and in bringing them together to create a final product, right? And some of the use cases of computer science, right, is creating games, could be apps, could be anything for the just in technology, right? Anything that you can use and feel the study of all of that is called computer science, right? Most of us have come across online shopping websites from Flipkart to Amazon, right? All of these are actually created with the help of programming. So let's come into what exactly a program is, right? Most of us in this day and age would have seen somewhere, either in sci-fi movies or anywhere, like your typical green screen with a lot of text running through, right? Contrary to popular belief, that's not what programming is. Programming, to all of us who have been in this domain, know that it is a detailed set of instructions, right? I'll actually read this out. A computer program is a set of instructions in a programming, is a detailed set of instructions. Actually, that should also be, it should be detailed set of instructions in any particular programming languages, right, for a computer to execute. So you basically, as a user, I'm telling my program what I want it to do, right? So it could be as simple a program as to add two numbers that you can see on the right side of the screen, right? This is a basic Python program. Now, what is Python? Python is a programming language, right? Typically, like how us humans use English to teach one another, we use the same thing, but computers use something called as programming languages. Those are similar to what we use to interact with one another. So we use programming language to interact with the computer itself, right? So in this is an example of a Python programming language, which basically, and in this program, it basically just adds two numbers. As you can see, line number 3 and 4 show us to take an input of two numbers. Line number 6 just adds those two numbers like how a normal human would. And line number 8 will just show us the output of that. So in this, most programs, or all programs actually, take in always an input, some form of input. Either it could be the touch in your mobile screen, it could be the touch. In your computers and laptops, it's basically your keyboards, your mouse, and if you have a touch there also, it could be the touch screen there. And it gives an output. And in this case, in the program that you see on your screen, the output is basically the addition of these two numbers, right? The output is, I've shown you the output in the last line. The output is just basically addition of 25 and 75. 25 and 75 are numbers that I have entered into the program, and the sum is basically 100. That's come out from the program itself. That's basically the output, right? An output in the real world would basically be when you perform a click, which is your input, you would see it on your screen, right? You click a button and the page loads or some other form of output happens, right? Now, typically these programs, whenever they are written in a text editor. A text editor is just basically a notepad. Your notepad could be text editors, right? A document file, right? Many of you have used MS Word. That could also be a text editor. So they're written, these steps of instructions, these programs are written in these document files. And from there, for the computer to be able to execute it, we actually take these programs and either compile or interpret them, right? This, you can think of that as translators. So we convert normal English to computer understandable languages, which is binaries. So computers, unlike normal humans, they do not understand English. So they understand just bits and bytes. And bits and bytes are just basically ones and zeros, which computers can actually understand. Okay, so these interpreters or compilers, they take the code that's written in human readable format, and from human readable format, they convert it into computer readable format, which is binary, right? That's basically the top step up here, right? And once they are converted into this computer or machine readable format, they actually exist on the computer. And once they are executed on execution, right? So they actually become a process, right? Process is nothing but an executable that's running. So you could think of, what can I say? Yeah, you can take your YouTube application. So your YouTube application, when it's sitting on your computer, not running, is just basically an executable. That means it's a program that's ready to be understood by the computer. And once you execute the same program, either once you click on it or once you open the application, it's when it becomes a process. And this process, like from the bottom half of the diagram, you can see it can take any sort of input, right? In YouTube cases, you can click on YouTube feeds, right? Whatever feed you're able to see. And the output data is basically it loading new pages or even it loading videos onto the screen for you to be able to interact. Comment sections, right? All these are outputs that you can see, right? And for all of these programs to run, or these processes to run, they require some form of storage and memory. Now, this storage or memory is similar to how humans store and retrieve memory. That means you're able to store it in a particular place. You learn something, you store it in a particular place in your brain, and you're able to retrieve it when you want to talk, right? Yeah. And some basic concepts in programming. Okay. So for us to uh, write any sort of program, right? Whether it be in a text editor or in a block-based program, as we are going to do today, you need to know some basic concepts. Now, we will add on to these concepts as and when we progress through the course. But for today, we'll be learning about 5 major ones, right? These are variables. I'll actually run through this with examples in the further slides. But they are variables. The flow of variables are just basically, you can think of them as containers, right? Like containers you have in your kitchen where you can just store whatever you want. It's left to the user to store whatever data that they want in these containers. It could be numbers, it could be strings, like of any sort. Okay. Flow control statements. What are flow control statements? You can think of flow control statements as, you can think of them as a roadway, right? You're going through the roadway, and at one point, if you want to reach a particular place, you branch off in the roadway or you take a right or a left. Similarly, programs have a similar path. They are always sequential in nature. That means they always run in a line, right? If you've written a program in an entire line, you could think of them as this, right? See, in this program, it's in a single line, and they'll always be running in a single line until and unless they're told to do otherwise, right? Yes. So let me actually run through these with the examples itself. Variables as a, you can just store age is the container in this case, and it stores the number 25 in it, right? And in this case, name stores my name. My name is Tarun, right? So it stores Tarun in it. So you can actually name this container whatever you want. It's left to the user to define what the container is named, and also the value it holds is also left to the user to define what value it holds, right? And typically names are kept that is easy for us to understand. In this case, age, my age being 25 and my name being Tarun. So I've just kept it simple and easy for me to understand, right? uh, and second one being flow control statements. Second one A was loops. uh, like I told you, typically programs just run in a single file, like how a road is. And if we want the program to repeat a particular set of code or a particular set of instructions multiple times, we use loops. So in the case of counting, let's take, we want to count from 1 all the way up to 100, right? Instead of uh, writing every single time add 1 to the previous number, we can use a loop to say, hey, look, take this number, add 1 to the number that you have already calculated. That means you start off with 1, you get 2, you take 2 and you add 1, you get 3. The same repetition we can perform to get the next number. So you can do that via a loop, which we will see shortly in the demo, right? Then we have conditional statement. Second part, uh, being branch statements, right? And conditional statements or branch statements, we call them, they're interchangeable in name. So these branch statements only are performed in case of a condition being met true, right? So let's just say we have a grading scheme, and in this grading scheme, we'll say, hey, look, everybody from the grade above 90 is given an A plus. Everybody below 90 up to 80 is given A minus. 70 to 80 being B plus. Similarly, the grading scheme follows below. So the computer would say, hey, look, given a mark, give me the grade, right? So it would look something like, hey, look, in this case, actually, I've given an example right here. If the number is greater than 10, right? If 10 is greater than 5, sorry, if 10 is greater than 5, only then run this block, right? If it is not, this section of code will not be run, okay? So there are many use cases to this. These are just basic building blocks of any programming that you'll ever do. These are some things that you'll always use irrespective of the simplicity of a program. Right? And the third type being data types. Now, what are data types? So when we talk as humans, it is very simple for us to easily understand what the difference between numbers and strings. But computers don't easily make this differentiation. So us as users have to specify these with a bit extra care. Okay. So every time you specify a variable, right, this container, you also tell what this container, you also add a little bit of metadata. Metadata is little extra data on what this container actually consists of, right? Is it a word? Is it a number, right? Is the container empty? Even that's also sometimes that we can specify. Or does the container also contain something that's big, right? In this case, big being a string, right? So I'll run through these data types on the right. Here you can see the depiction of it in the coding based platform. I'll run through these on the right. So integers is basically like a typical definition of an integer, right? It's anything that's negative and positive that does not have a fraction in it, right? It could be -1 all the way up till -100, but that does not have a fraction in it, right? Floating point numbers. Floating point numbers are numbers that are on the real line. You can pick any number that's on the real line, and you can pick them, and those are numbers that are represented in floating point numbers. Right? They can depict any numbers, either be a fraction or a real number or a natural number. Strings are basically just, you can think of them as a bunch of characters that are just joined together. Those are just basically strings. They're literally any character on the keyboard that you can actually physically see on your screen. You can just combine these and store them as one variable, right? And last one being null. Like I told you, containers can be empty, and those are stored as null, okay? And different programming languages have different ways of depicting null. Like you'll have null as the keyword itself, or none. Both of these are basically the same. It kind of is left to the programming language as to what they use to depict these two. Okay, so now parts of a program. So typically, whenever you are writing a program, these are the things that you'll either come in contact with or you need to be aware of, right? So the software parts of a program are basically your IDE, and the IDE is anything. It's basically an integrated tool used to develop a program, right? In our case, I'll be showing Raspuri. That is also an IDE, but that is for a block-based IDE. Many of you might have come across or even used VS Code. That is also an IDE, right? And there are many IDEs that people can use. You have an interpreter or a compiler. So every programming language internally, like I showed you in, I think, slide number 3 or 4, they're converted from a higher level language, like a human readable language, down to a machine readable language. So to convert it from this higher level to a lower level, we basically use the interpreter. And once this is generated and this machine readable language is ready, you can execute it through the program. And the hardware components are anything that the program will come in contact with when doing any sort of when it's running as a process. It'll come in contact with these. So the CPU is basically what is used to run this program. So once it becomes a process and once it starts running, the CPU is the one that's executing these set of instructions that are generated. RAM is like the memory that I specified, which stores anything. So if you were to add two numbers 1 and 2, you get 3, right? You store it in a particular place in these containers. These containers, these variables also are stored in memory itself, right? They're present in memory somewhere, and upon on a need basis, they're retrieved, right? These IO devices, like I told you, these keyboards and mouses are the ones that you use to input and get output out of them. Okay. Yeah. So we have steps in creating a program. So for any program, right? This is a little bit in depth about how you create a program and maintain a program, right? So you define the problem. So let's take a very basic example, right? If I were to now make a program to just add two numbers, right? The basic goal of the program is to just take number A and number B and add number A and B, right? A and B being the containers that they're stored in, or the variables, which is the other word, right? Let's define the program. So a definition of this program would be add two numbers, right? Write a program to add two numbers. That's basically the definition, right? So you plan the solution, right? So when you're planning the solution, there are two ways to actually plan the solution. You can either write an algorithm. An algorithm is just basically a detailed step-by-step instruction, but that's written in more human readable format, right? It's more in written English, you can say, right? You write step one and then you write, hey, look, step one is to get the value of A, step two is to get the value of B, so and so, right? And you'll say step three being add A and B, right? So you add A and B, and step four being display the value of the sum of A and B, right? So in case we were to enter 1 and 2 for an example, the output would be 3. So in the algorithm, it would basically give you a detailed step-by-step instruction of what will happen in a program. Flowcharts or pseudocode. Flowcharts are basically just you take the same algorithm, and if you were to convert it into a pictorial representation of it, the same algorithm in a pictorial representation is basically a flowchart. Number 3 is programming language. Okay, so once you've defined the program and you also know how to solve this particular program, you need to implement this, right? You have the problem statement ready, you have the solution ready, but you need to implement this. Now, to implement this, there are various programming languages, right, which are available. As of today, we'll be looking at a block-based programming language, but the other ones, just for mentioning, are Python. Python is a pretty simple and easy programming language for many beginners also, right? Then we have C++. This is also a programming language that you can use, which is a little bit more lower level programming languages, right? So then you implement based on which programming language you pick, you implement in this, right? And the choice of programming language is left to the user itself, right? Whoever is writing this program, right? And then you write this program. You take this algorithm and implement the same in the particular programming language. And once you're done with it, you run tests on the program. Typically with smaller programs, you already know the input and the output, but as the programs get bigger, it becomes difficult for us to know if we have done any errors. So what we do is we run tests of program where we know the input and we know the output, right? For most of us, we know that adding 25 and 25 will give us 50. So we'll give the program inputs as such, and we'll expect the output to be 50, right? We run the test similarly. Then we have debugging. So debugging is when you test the program and you aren't really getting the type of output that you really require. That means there is some sort of error in the program that you have written. It could either be in stage 2 or in stage 3. That means you have either created the incorrect algorithm. That means your methodology for approach to actually solve the problem is incorrect, or your implementation of this methodology could also be wrong, like one of these two. Okay? So you go back, you visit step number 2 and 3 and say, hey, look, somewhere here is an error. You find the error, you fix it, and then again you go back to step 4, you fix the program, and then you go back to again step 5. If there is an error, you do step 5, right? Step 6 and 7 is mainly to maintain and run the program. That means you document it. So for somebody else who's going to look at your code, right? You want to write comments or you want to document it for somebody else. So that makes it easier for somebody else to understand. And Step number 7 being maintenance. We'll actually skip over this. This is not something that a beginner would do, but we will run through this in the further webinar talks. Yeah, what are some use cases of program? Like I've already previously mentioned, so most use cases of programs all you would have widely seen, right? It could be either robotics, it could be web design. Web design is the ones that are widely used, which most of us think software engineers do, right? Could be game design. Most of us have played video games. At some point was a program just, and then once they were able to publish it, you are able to use it. So yeah, mobile applications, healthcare solutions, right? Your thermometer, right? Digital thermometer is also basically a program running inside a thermometer that basically detects your temperature, that's your input, and gives an output that is shown on your screen. And off late, the biggest buzzword being AI, right? So even artificial intelligence is nothing but just a program, but a program that is a little bit more complicated, that's able to actually understand a lot more than most humans can. Right? Yes. So finally, we come to what no-code technology is. So contrary to most people, code is written in a text editor, right? You write them in simple plain English, but we have a Raspuri, a block-based coding system where blocks are pre-built, right? So what are the advantages of these? Right? It's all drag and drop. So most of what you'll do is ready. It's all ready and is present in a very basic sense. That means you want to enter numbers, we have blocks to enter numbers. You want to perform operations, we have blocks to perform operations. You want to do any sort of mathematical, even graphical operations, we have most of these, right? Why are we introducing block-based programming language in our very first webinar? Because it is one of the easiest way, even for a kid from grade 6 all the way to anybody who's learning programming who has no understanding of what programming is, to learn, right? If we were to we do not want to uh, teach a difficult programming language which has a lot of syntax and uh, other things which they'll not be able to easily understand, right? I think I've run through 3 points. Yes, collaboration and sharing. So in this programming environment, you can easily store, share, retrieve it, programs to. So if you were to write a program to just add two numbers, you can share it with other people, and they'll also be able to learn through you, and very easily since it's block based, right? And this is the foundation for advanced learning, right? So since you're able to, if you're able to create a program in this block based programming languages, it will be 1,000 times easier for you to convert that to a more complicated language. And interdisciplinary learning. So interdisciplinary learning is basically you can use different facets of your life that you have learned, whether it be it math, science, or any other thing, and you can basically implement that. So today we'll also look at how to actually implement a very basic and a program math question as to how do you generate area of a particular circle, right? And we'll also generate area of a circle for multiple radius values, right? So let's look at the live demo. So let's go to Klaritree.com. So I'll show you how to actually be able to enter the Raspuri website, right? So Klaritree, this is our landing page. So once you go down here, you should be able to go and try Raspuri. This is our multilingual coding platform that we have right now. So once you hit try, you just hit get started. I've actually already logged in. Just log out. So if you haven't logged in already, right, or you don't actually have an account with us already, you can just sign in through Google. Once you hit sign in through Google, it'll just ask you which email address to use, and once you click on that, you will land on this landing page, right? So in this landing page, we have these, and Raspberry is the topmost one. So we will this. Give me a second. Let me just grab a glass of water. Yeah. Um. Yep. So once you land on this page, you run into projects. Right. I'm just going to open this in a different tab. So these are your projects tab. So this is where all the projects that you create will reside. Right? And I'll show you the help tab here. So in this help tab, we have different blocks. So before this, I'll just create a new project. Let's do average. So let's create a basic program to actually calculate the average, right? An average of n numbers. Create this project, and here on the left hand side, you can see a lot of logic blocks are available, right? So these are all the blocks that are available for us to use, and the descriptions of all of these blocks, which I will shortly be explaining, are actually available in the help section, right? All of these are available for you, and they're not only available to you in English. So if you're a guy who's prefers a different language, right? In my case, I will just choose Kannada, right? So in this, all these blocks are translated to the respective root languages, right? So, and they're easy to understand also. You can skim through all of these on our platform. Yes, right. So now this, what you're seeing right now, is the Raspuri page. Right? This is your project page. Basically, you're actually in the project window at the moment. So in this project window, this is your editor. So wherever my screen is right now, this is where you're editing, creating programs. So I'll just drag in a block. Right? So very basic. Right? So as you can see, this is where all your blocks will reside. This is your output window. So whatever operations you have to perform on this, if you hit to hit run, you can actually see this. So in this, I'll just hit, so you can see the output down here. You have your input up here. And on the left hand side, you can see various different blocks that are available for you to use, right? Like I told you, it's interdisciplinary, so you can use it for a lot of different things. Whatever you do in your daily life, you can definitely convert them very easily into programs here, run them here, and I'll also show you how you can export it to a different particular programming language in the end, and also run it on your computer if you are aware with a more complicated programming languages, right? More advanced programming language. Right? You have logic blocks. Logic blocks are anything that control the flow. Like I told you, conditional statements, those are down here, right? You can see the if case here. So these all control the flow of program. So the loops also we came across in the slides. In this, we will run through a very basic one. Repeat here. Repeat is basically a loop. Math. So all math related operations you can find here, right? From addition, subtraction, any sort of mathematical operation you can find here. Text blocks are usually used to input or output data from the program itself, like, right? So in this case, I'm able to output. There's also one for input. This is the one I'll be showing this shortly. List colors. These are advanced ones, which we'll cover shortly in the next few coming list colors and functions, which we will cover in the upcoming webinars. Right, variables. Like I told you, these are just containers for you to store data. So those are these are ones that we'll use today. So in today's program, this very first program, we'll just try to calculate the average, right? So let me take a very simple program which everybody can understand. Let's generate the average of your marks that you have scored in school, right? So I'm taking the definition of this problem will be to add the marks that you have scored and to give the output as average, right? So I will take five subjects, right? So we'll create, so to store these five subjects, we'll require five different containers, right? So we'll generate variables for them. So we'll generate English. English has one. Great. What? Canada as the next variable. Great. Math. Assign. And what is another subject that I can take? Social. The five variables that we have. And so for each of these variables, we have to assign values, right? So you have a container that's ready. Now we want to assign these values. So let's just say I am a really good student and I score good marks. Now to actually store these values, we will use the math block. The math block has a number up here, right? So you can either drag and drop it here, right? And edit these numbers. So I will say, hey, look, in English, I'm a pretty good English major. So I will say, hey, look, I have 95 marks. And let's just take Kannada. Choose Kannada, and in Kannada, I am decent, so I get 80, right? So this is a direct way. So this is a way you're directly entering data into the program itself. But what if we wanted to input data uh, through, like every time you want to run this, you want to input different data. We can use a different way of actually entering data. Let's say for math, I will input data, but I will put data through this. So you'll prompt to get a number, right? They'll say basically the right. So once you were to run this, it will just basically prompt you with this. That similarly with taken all the social science, right? Just for social science, I will just enter a constant value, simplicity, that being 90. Right now, we have taken these inputs, right? So now, how do you calculate average? So average is basically the sum of all your inputs divided by the number of inputs. In this case, you have inputs as 5. So you will basically sum all these up and you will calculate the average by dividing them by 5, right? So how will we do that? We'll create another variable, call that sum. Drags. Once you were to drag sum here, we will add all these. Now, how to add? So like I told you, we have a math block, and in this math block there are operations. There's this block down here that you can actually use to add these numbers, right? And to add these numbers, you can enter the numbers here, that you can enter constant numbers here, or you can also drag in variables down. So in this case, I want to add many of these. I will just add my English, Kannada mark, and do this multiple times, but oh, this is the wrong block. Variable. Right? So you want to change the operation. Oh, yes, there we go. So this should be good, right? So you can also edit this in case you wanted to subtract for some other program. You wanted to add, subtract. You have all these basic operations that you can perform. Just drop it down. You'll get all these. So now let's just print some. We'll print this. So it's basically going to add whatever you enter. So let's read here. I'm really good at math and 90 in science. Right, 455, which is correct, right? 95, 190. Yes, that's correct. So that's 455, which is the exact number that we wanted. So now if you were to calculate average, which we would again go down to the math block. Oh, before we go down to the math block, let's actually initialize an average container, right? Because we want to store this output into the average container. That's page 2. Operation basically will be sum divided by. So since we already know the number of elements that we have, that's 5. We would divide it by 5. Print output x. Then we will and print this. So now if I were to run this with the marks for math, it would basically be 100. If I'm not wrong, I entered 90 last time. And basically your average is 91. Since you have, or if you do not want the print, means you just don't want to see the sum, or you just want the average, you can just do this and you'll only find the average here. There we go. And obviously you can enter, every time you run this, you can enter different values. For some, let's just say you scored 95 in math and you were to enter 100 in science, or let's just say 99, just different input. Right? You'll see that the output also changes based on what input you give. And this is a program just to calculate the average of numbers. Let's also do another program to calculate the area of a circle. Right? Open this. Area of a circle. Okay, so here, start off by again creating a variable with radius, right? So let's define what we want to enter. Radius circle. Enter the radius of the circle. What do you do? So the formula for the radius of, oh, sorry, the area of a circle, it is basically pi r square, right? Pi into r, right? R being the radius. In this case, I've actually mentioned. Actually, we want a number input. So let's take the area of a circle is this multiplied to radius. This is r squared and now you want to multiply pi. So the way you multiply pi is simply take another block of this, attach this, but you go into the math block, you also have a block that actually has all commonly used symbols, pi, right? That's 22 by 7 for um, uh, anybody who wants to know the value of pi, 3.14. You have e, you have theta, square root of 2, square root of half, and infinite. So we'll use pi. So you again multiply this. So pi r squared, area of a circle, so attach it, and now whatever is on this side, you can easily, it calculates the value. X, we print out the value of, yeah, right? So for a circle with radius 1, that means 1 unit, the answer should be 3.14. Okay? So we'll see if that is right. This, let's just say 1. So you're getting the exact value, 3.14. Right? This has a higher precision to it, but yes. Now let's go one step ahead. Like, this is pretty simple. Let's actually use control statements to actually generate uh, the radius of a circle, but from given a radius value of 1 all the way up to radius value of 10. Let's generate this program. Okay, so basically the problem definition is here is for a circle with unit radius, that means radius 1 all the way up to radius 10, generate the area of the given circle. So we will not be prompting this time, we do not require, but we will be using flow control state. Right? So repeat 10 times. Initialize a variable to actually, but actually we already have radius. Start off with radius equal to 1, right? So we want to calculate the area of a circle starting with radius equal to 1 all the way up to radius is equal to 10. So at every iteration, we will increase the radius value by 1. The change statement, right? So we will change the radius starting off with radius 1. At every iteration, you're actually increasing the value of radius by 1. Okay, and you're going to do this 10 times. Okay, this will actually run 11 times, but the circle is equal to, okay, we are also printing the area of a circle. So if we were to run this, we'll see the area of a circle with unit radius, that's radius is equal to 1, this radius is equal to 2, 3, 4, so on up to 10. Right? Yeah. And yes, so I think I've covered most of the basic operations, right? And last but not least, to show you a very basic example of, let's do that in this, use the logic block and check if average the, no, sorry, logic block. Okay, right, so we will check if the student scores, if the student's average is anything above 90, we will say he's a good student. Okay. Greater than, set the threshold to be 90. We will say print is a good student. Okay. So now you can see in this case that's already been run. You can actually see that he is a good student, right? So he's scoring averages above 90. Okay? So if I were to run this, he scored, I think, I forgot the input for this. I think it was 95 and 99. 95. He is a good student. Okay. So now let's run a case where he actually scores below 90. So let's just say for some reason he scored 40 on the math marks and 60 on his, right? He just scored 73. 73 does not meet the minimum threshold of 90 to say he is a good student, right? So this way you can actually use conditional statements to run a piece of set of instructions that you want to run given a condition is met, right? And this is the condition was if the average is above 90. Yeah. Also, one last thing that I should have mentioned at the start was that you can also change the language based on your preference, right? So you have these many languages that 9 languages, if I'm not wrong, that is supported by us at the moment. So you can just say, hey, look, I want this in Kannada. So you have this entire thing that is easily visible to you in Kannada. You can also type in Kannada, right? I don't have a Kannada keyboard, so but you can also view this. All of these are visible. Any other language of your preference. Just take Sanskrit just as an example, or Hindi also. Uh, and yeah, you can program in them also. Let's go back to English, enter this, and any after you've written this code in your block paste editor, you can also view this code. Actually, if you go to the code section on the right hand side, you can view this in a few different programming languages, but the ones that is of interest today will just be Python, right? So whatever we have done, it converts it from the block based programming to a Python program that you can actually export. So if you export this, it'll actually just download onto your system. You can export this and you can basically see a very basic Python program that does calculation of the average, and it tells if he's a good student or not. Yeah. That if any of you have any questions, I think you can put it down in chat, or if you want me to do another program or anything that you guys are still confused about, please you can go ahead and ask in chat. Have a look at it. Yeah, I'll give you a few more minutes. Uh, Okay. I don't think there are any questions. So we'll be ending today's session here. Be on the lookout for next week's session. It's a pretty interesting session with practical. Um, with a practical show on electronic components, right? Will be presented by Veda Prakash, right? Be on the lookout on your emails, and give me a second. Let me put out the outro screen. So please follow us on all these socials, right? And still, you can stay up to date on all these socials. We'll be posting on all our webinars, our free sessions, any courses that we come up with, or workshops that we conduct on these socials. Thank you, everyone. Thank you for joining today's session. Hopefully, look to see more of you in the next few sessions. Thank you.